Welcome back to the deep dive. So today we're going to kind of ignore the flashy screens we usually obsess over.
Yeah, we're going behind the wall.
Exactly.
Right.
Behind the wall into the invisible plumbing. We're talking about a piece of hardware, the Kramer VS-8UFX.
It's a bit of a mouthful. The full name is the 8-port 12G SDI Matrix Switcher.
Right. And it basically sits in a dark rack somewhere, but it's the only thing that's stopping your favorite live broadcast from, becoming a glitchy mess.
It's funny you call it plumbing because that's really what it is. It's a high-speed traffic control for all your video signals.
And when we say traffic, we're not talking about like a Zoom call or streaming a movie, are we? I think a lot of people hear 4K video and just think, oh, I get that on my phone.
That is the biggest misconception. Streaming video is heavily compressed. It's like a freeze-dried version of the real thing.
Okay.
This Kramer unit is handling raw, uncompressed video. We're talking 4K resolution, 60 frames per second with 4.2.2 color sampling, just a massive amount of data.
So if Netflix is a garden hose.
This is a fire hydrant that's been ripped off the sidewalk.
Got it. And that brings us to the 12G in the name. That's about speed, I assume.
It's all about bandwidth. 12 gigabits per second. You need a pipe that wide to move all that data without dropping a single pixel.
And if you bottleneck that, even for a millisecond, in a live broadcast,
the screen goes black, or you get those, the weird green and purple block.
Alien artifacts, yeah. Now, usually with these kinds of switchers, the hardware is pretty rigid, right? You buy a box, it's got 4 inputs, 4 outputs, and that's your life now.
That's the classic frustration. You get to a job, you suddenly need 5 cameras, but you only have 4 inputs. It's a nightmare.
So what's different here?
This is the aha moment with this device. The ports are, they're agnostic.
Meaning they don't care if they're an in or an out.
Exactly. They are completely interchangeable. It comes with 8 ports, and by default, it's set to 4 in, 4 out.
But you can change it.
Yeah, you just go into the software and say, okay, today I need 7 inputs and only 1 output, and you just do it.
That's incredibly convenient. It's like a Swiss Army knife where you can decide you need more blades and fewer screwdrivers.
It is. But here's the other big problem that hardware like this has to solve. Distance.
Right. Physics. The signal degrades over a long cable.
It does. The data pulses start to blur together. It gets noisy. Now, the cheap way to fix that is just to amplify everything.
Which is like just shouting a garbled message louder, isn't it? You're just shouting the noise.
You've nailed it. You're just amplifying garbage. This unit does something much smarter. It's called equalization and reclocking.
Okay, so what does that actually do?
Well, instead of just boosting the volume, it reads the weak, messy signal. It figures out what the ones and zeros were supposed to look like, and it rebuilds them perfectly.
So it's not making a photocopy of a faded page. It's more like a scribe reading that page and rewriting it in perfect handwriting.
That is a perfect analogy. And because it does that, you can push that really heavy 4K signal up to 80 meters.
Wow.
And if you're just doing standard definition, you can run a cable for 350 meters. That's like over 3 football fields, no problem.
Speaking of problems, let's talk about the actual switch, the cut. We've all seen that little flicker or jump on live TV when they change cameras.
The dreaded vertical roll. Yeah, that happens when the cameras aren't all in sync. This Kramer has clean switching, but it does need one thing.
It needs gen lock.
It needs gen lock. You have to get all your sources locked to the same beat.
I always think of it like a metronome for the whole studio.
Or a drummer in a band, right. If all the cameras are musicians, gen lock makes sure they're playing in time. When they are, this switcher can make the cut in the tiny gap between video frames.
So the viewer literally never sees the seam.
It's instantaneous. You can't see it. It's seamless.
So let's put it all together. This thing costs around $2,800. It's not cheap, but it really sounds like you're buying insurance.
You're paying for reliability. You're paying so that when millions of people are watching, the invisible part, the infrastructure, doesn't fail you.
It's funny, we sit on our couches demanding higher and higher resolution. But we never really think about the poor engineers just trying to push all that data through a copper wire.
And that really is the lingering thought here, isn't it? If we need this level of engineering, this reclocking and flexible routing, just to move 4K video 80 meters.
What on earth is going to happen when 8K becomes the standard?
The data rates will double, then quadruple. The physics of the problem just get harder and harder to fight.
A challenge for another day, I suppose. We'll leave you with that thought. Thanks for joining this deep dive, and we'll catch you on the next one.